Hi, welcome to session 9. We are doing our normal recap. I have got this available as a printable, so if you wanted to print it off, you could. If not, you'll be working from the screen. What I will do is I will get rid of myself so that I can expand the page, and then you can kind of see it a bit bigger, and I'll scroll it up, and you just need to pause at the right time for answering the questions, basically. And I'll do the answers in exactly the same way. So if you either use the printed version or get yourself set up with this, hit play when you want to move the page up or when you want to mark, okay? Here are your answers. Just need to be pausing and playing. Just kind of make it work for you. I'm going to scroll through slowly. So hopefully that went well. Just make myself a little bit bigger so you can see me nice and clearly. Okay, so probability and relative frequency. This probability is obviously a big topic. We're going in around the grade 4 with this, and it is using a fact about probability that comes really from the early stages of learning it. And it's the fact that probability adds to 1 that would enable me to find the missing probability for yellow in this table. But just before we just crack on with that, I want to give that background knowledge just a little bit of time so that we can appreciate exactly why we are doing what we're doing. So if I was to say the probability of it raining was 0.2, then the probability of the opposite thing, of it not happening or not raining, would be 0.8, because between the two events, either it's raining or it's not raining, one or the other is definitely happening. So it's a certainty that it'll either rain or not rain. And that is where this scale comes in. So our probability scale is 0 to 1. 0, absolutely impossible. 1, it's a certainty, it's going to happen. So what I've got on this probability line is 0.2 for rain, and then 0.8 for no rain. And together, 0.2, 0.8, together, they create that whole, that 1. And it's that fact that, like I say, helps us complete these tables. So all I actually need to do is add up what they've given me, plus 0.1 plus 0.3. That equals 0.65. I need to take that away from the 1, which is going to give me 0.35, and that is the missing value. Now, the working out is really important. If you're sort of sitting there thinking, oh, I could have done that in my head, don't. It's a 2-mark question. And if all you do is write down the answer, you've got yourself 1 mark. They're really looking to see that understanding about the 1 in your method. So it could be 1 takeaway, everything else, or you could have done this and then showed plus 0.35 equals 1. It doesn't matter how you show it necessarily, but you must have some of that working out down that makes it clear, you know, it adds to 1, and this isn't just a lucky guess. Okay, so that is the method for finding a blank in the table. Okay, so I've got a couple of tables that I've prepared that we can look at. So this table is virtually the same. okay? It's got a number I don't know here. The only difference is they put an X in there. So don't let that put you off. That could be blank, but it's not, it's X, but it's the same thing. So I want you to hit pause and have a go at that question. Okay, so we've got 0.15 plus 0.2 plus 0.2. That's adding up to 0.55. One, take away the 0.55, and I've got 0.45. So 0.45 is the missing value. Nice and easy, really, isn't it? Okay, here's a different table. I still want you to have a go. I know it's got 2 blanks, but just go for it. You know it's got to add up to 1. What do you think we're going to be doing there? Okay, so give it a go. Okay, so 0.2 plus 0.3 is 0.5. And 1 take away 0.5 is 0.5. So I know that these 2 blanks added together is going to be 0.5. So if I divide that by 2, I would get 0.25, and those are the missing numbers that would go in there. So I'm just sharing it out equally. If I'm not supposed to share it out equally, they will make it clear in the question. So that's being shared out equally. Okay, let's have a little look. I've got 2 more questions that I would like you to do now for me. Okay, so fill in, so we'll label it, shall we? That's question 1, that's question 2. I want you to hit pause and literally do both those questions and press play when you're ready. Okay, so the first one, we've got 0.12 plus 0.32. That's adding up to 0.44. 1 minus 0.44 is equal to 0.56. And when I divide that by 2, I will get 0.28. So I've got 0.28 and 0.28 in the first one. They are both X, so it's shared equally. Okay, and then the same thing is happening on the bottom one. So you should have added them up and got 0.68. We'll do 1 minus that to get our 0.32. Divide it through by 2, and we've got 0.16 and 0.16. Now, we're going to move on into the relative frequency side of it. Before we do, I am just going to put a little warning in. When you go to do the practice questions at the end, I have thrown a little extra in for you to think about. And I don't want to give too much away, otherwise it's just me telling you how to do everything, and that's not sensible. You've got to be able to kind of take what you know and apply it to a question that you haven't really seen before. But I do want you to, oh, that little one didn't show, there it is. I do want you to think about this, okay? I could have given you a table with 0.1, 2x, x, and let's say 0.3. You've got to be careful with this, and I'm not going to tell you how to do it because I really want you to try and work through this when you get to it. But just be really careful, because that means that this one is going to be twice as big as this one. So if x worked out to be 0.1, which it wouldn't in this case, but like I said, I don't want to show you how to do this. If this worked out to be 0.1, this would be double it, so it would be 0.2. Hopefully that's made some sense and will help you when you get to those questions. And I hopefully haven't put you off from the entire session doing that. All right, so relative frequency is when they're often talking about experiments. So this question here, or both these questions are labeled up with spinners. So we're saying that there's a spinner and it's labeled 1, 2, 3, 4. And the probability of landing on 1 is 0.12. And on 2, it's 0.32. So they haven't got an even chance. They've got a different chance of landing. And that's true of this one as well. So if I was to spin the spinner 300 times, they wouldn't all equally land on 75 each. Okay. So let me show you what I mean by that. So if I span it 300 times and they all had an equal chance, 1 would come out 75 times, 2 would come out 75 times, 3 and 4. Together, that adds to 300. So that 300 is being divided evenly out because they've all got a fair chance of being landed on. That's not the case when you're looking at this type of table because they've all got a different chance, which means that distribution of the 300 isn't even anymore, and more will go to one number than another. So the way that we solve these is really simply, it's not complicated at all. So if I was to say, let's say from table 1, I'm going to spin the spinner 400 times. Okay. And I want you to tell me the probability that I land on a 2. So what I do is I go to the table and I find out what the probability for landing on a 2 is. And I'm just looking at the first table. So that's 0.32. So the probability is 0.32. And the number of times I spin it is 400. So these are the 2 key numbers that I've got to put together. And I want 0.32 times 400. If it was a fraction like a third, I'd want a third of that 400. If it was a half, I'd want a half of that 400. It's a decimal. I want 0.32 of that 400. And of means times in maths, which is why we're using the times operation. And then you literally just pop that straight into your calculator and you get the answer 128. If you were on a non-calculator paper, then you would be doing this by hand. And there you can double the 32, double it again, and just get your decimal point in the right place. These are generally on calculator papers. Okay, I'd like you to have a go this time. So it's still being spun 400 times. What is the maths you'd use to find the probability of it landing on 3? Hit play when you're ready. Oh, you can just about see it. There we go. Okay, so the probability of it landing on 3 is 0.28. So I'm going to take those 2 numbers, multiply them together, and it's going to give me 112. And that's it. That really, I mean, obviously, if you don't know how to do it, it's not an easy thing to guess your way through, but equally, once you understand it, they're pretty easy marks, hopefully, that we can pick up. All right, let's do table 2 this time. So this time I'm going to say that the spinner is going to be spun 200 times. And I want you to tell me the probability of getting a 4. So hit pause and press play when you're ready. Okay, so you should have gone to the table. Probability of getting a 4 is 0.4. So the mass is 0.4 times 200. And 0.4 times 200 is 80. Okay, so well done if you got that right. Okay, I'm going to do a slightly different question this time. I am going to say I'm spinning it 200 times, so same as before, but this time I want the probability of it landing on an odd number. Okay, so the probability of it landing on an odd number. So hit pause and press play when you're ready. Okay, so I've got odd, for the probability for my odds are 1.28 for 1 and 1.16 for 3. So I add those together, which gives me 0.44. So that's my probability of getting an odd. I times that with my 200. So times that to my 200 and I get 88. And if you got that right, then really, really well done, because you didn't know to add them. I was hoping it would be kind of like intuitive, but you didn't know. So if you did that, really, really well done. And that's kind of the only way they can make them a little bit harder. So that's everything that you need. We've got, again, these are worksheets that you can print. Actually, let's just go in again on that for a sec. So I've done these in the style of the exam question. So the exam question will give you a little bit of information about what the table's showing us. And then it'll ask a couple of questions. So it should have a real feel for how it will look on the exam. So there's 2 pages, because they're quite big, and I wanted to get a bit of variety in there so that they could start off and then get into some trickier ones at the end. Please remember, you have everything you need to solve this. There's no new knowledge. So if it's a bit more of a thinking question, then work through with the information that you've been given to try and work it out. If you're unable to print, then I'm going to do what I did with the do now. I'll disappear, I'll expand it, I'll slowly scroll through it, so you can just pause and play as and when, and I will do the same with the answers at the end. All right, so well done. That's hopefully a nice, quick, easy kind of win on the whole GCSE study, because it's not a huge thing to learn. Bits to remember that are very important. All right, I will see you next session. Well done today.